If you want to understand why your body is accumulating cellular damage faster than it can repair it, do not look at your genetics. Look at whether you are giving your body the one compound that activates its own built-in DNA repair system. That distinction matters more than almost anything else I will ever say on this channel. Because if the damage is genetic, you have no options. But if the damage is accumulating because your body is missing a specific molecular signal, a signal that a single, inexpensive food can deliver every single morning, then the conversation changes completely. The food is broccoli sprouts. Not a superfood trend, not a supplement. The most concentrated known dietary source of sulforaphane, a compound that activates the NRF2 pathway, your body's master switch for antioxidant defense and DNA repair. This compound has been documented in over 3,000 peer-reviewed publications. It has been studied at major cancer research institutions for more than 2 decades. And your physician has almost certainly never mentioned it, because there is no pharmaceutical version of a broccoli sprout that can be billed through insurance. Every day you spend without this knowledge is another day your NRF2 pathway sits dormant while DNA damage accumulates without correction. How serious is that accumulation? And how long has it been proceeding inside you without a single intervention? The research answers that with a number that deserves your undivided attention. Research from the National Institute on Aging has documented that oxidative DNA damage, measured as 8-OHDG, which is the most validated biomarker of cumulative DNA oxidation in human tissue, increases by approximately 200 to 300% between the ages of 40 and 70 in adults consuming a standard Western diet. Not a modest elevation, 200 to 300%. And that accumulation is now considered a primary mechanistic driver of cancer initiation, cardiovascular disease progression, and accelerated neurodegeneration, not a downstream consequence of those diseases, but one of their root causes. That number is your cellular reality right now. Here is what happens when you bring that reality to a standard preventive care appointment at age 65. No measurement of oxidative DNA damage is ordered. No dietary recommendation for NRF2 activation is made. Not a single mention of the food that peer-reviewed research has shown can reduce 8-OHDG levels measurably within days of daily consumption. I am not saying your physician is negligent. The healthcare system generates revenue from treating the diseases that accumulated DNA damage eventually causes, not from preventing the cellular damage in the first place. That is not a conspiracy. It is an economic structure. And it has a cost that you are paying in your cells every single day. My name is Marcus Thornwick. I spent years in clinical practice watching a pattern that I could not continue to accept in silence. Patients managing cancer diagnoses, cardiovascular events, and accelerating cognitive decline, all of them downstream consequences of decades of unaddressed oxidative DNA damage, sitting across from me in appointments where the research on how to address that damage was sitting in peer-reviewed journals that no one was translating into the clinical conversation. The research on NRF2 activation and sulforaphane had been accumulating for 20 years at the time I was having those conversations. Scientists at Johns Hopkins and the National Cancer Institute had documented it in controlled human trials. My patients had never heard of it. I did not discover this science. I am the clinician who recognized that the person who will be sitting in front of a screen watching this video right now deserves to understand what that science means for their body. What they eat for breakfast can measurably affect the rate at which their DNA is being damaged and repaired. That recognition became a moral obligation. This channel is how I fulfill it. Here is exactly what I'm going to give you over the next several minutes. First, the biological mechanism, the molecular sequence through which sulforaphane activates the NRF2 pathway and initiates DNA repair. Second, the research from 4 distinct institutions documenting measurable reductions in DNA damage biomarkers in human populations. Third, the complete precision protocol, exact quantities, timing, preparation method, and the critical activation step most people skip. And fourth, the 4 specific preparation mistakes that cause motivated people to consume this food correctly on their shopping list and incorrectly in their kitchen. Each of those four things is a specific piece of biological knowledge you will own by the time this video ends. If I am about to deliver 20 years of cancer research in a single practical protocol, the fair exchange is 2 seconds of your time. Hit subscribe now so the next video reaches you when it matters, and then stay with me through everything that follows. Before the molecular details, I need to make the mechanism visible, because the biology will only carry real conviction if you can see it clearly first. Think of the NRF2 pathway as the master circuit breaker panel in a large building. In the utility room of that building sits a central control box, the panel that, when a single switch is activated, simultaneously brings online every downstream protective system in the structure: the fire suppression, the emergency lighting, the backup generators, the air filtration, the structural sensors. In a building where the panel is properly maintained and receives the right activation signal, one switch event coordinates the entire protective infrastructure simultaneously. Now imagine a building where that panel has received no activation signal in years. Every protective system is still there, still functional, still connected, but dormant, sitting idle, while the building accumulates the very damage those systems were designed to prevent. That panel is your NRF2 pathway. Sulforaphane is the signal, and the building has been waiting. NRF2, which stands for nuclear factor erythroid 2 related factor 2, but which simply means the body's master antioxidant and cellular defense regulator, is a protein present in every cell of your body right now. When it activates, it switches on over 200 downstream protective genes simultaneously. Genes responsible for neutralizing the free radicals that damage DNA. Genes responsible for repairing the DNA strands that have already been broken. Genes that clear the cellular debris that precedes cancerous mutation. Genes that suppress the inflammatory signaling that accelerates all of the above. Sulforaphane is the most potent known dietary activator of NRF2, and broccoli sprouts contain 50 to 100 times more sulforaphane than mature broccoli. The gap in concentration is not marginal. It is the difference between a clinical intervention and a side dish. And this is the part that makes the geography of human health impossible to ignore. The precise molecular sequence works like this. Under normal conditions, NRF2 is held in a locked, dormant state by a protein called KEAP1, which simply means the cellular lock that keeps the NRF2 switch in the off position. Sulforaphane chemically modifies KEAP1, releasing NRF2 from that locked state and allowing it to enter the cell nucleus, where it binds to a specific DNA sequence called the antioxidant response element, which, in plain terms, is the activation address where NRF2 delivers its simultaneous instructions to over 200 protective genes. The downstream effects are specific and measurable. Glutathione production increases, and glutathione is the body's primary internal antioxidant, the molecule directly responsible for neutralizing the free radicals that cause oxidative DNA strand breaks. Phase 2 detoxification enzymes activate, clearing carcinogenic compounds from cellular tissue before they can initiate DNA mutation. And NF-kappa B, which is the body's primary inflammatory signaling switch, the one that, when chronically active, maintains the cellular environment where DNA damage accumulates fastest, is suppressed. Most people believe their cancer risk is determined by their genes. Japan's cancer incidence rates are among the lowest in the industrialized world. The traditional Japanese diet includes regular cruciferous vegetable consumption, at concentrations 3 to 5 times higher than the average Western diet. A 68-year-old in rural Japan eating fermented cruciferous vegetables daily and a 68-year-old American whose physician has never mentioned sulforaphane are not experiencing different cancer risk trajectories because of different genetics. They are experiencing different NRF2 activation frequencies because of different dietary inputs. Two people, two diverging trajectories of DNA damage accumulation and repair, separated entirely by what one food delivers to one molecular pathway. The research that confirms this effect in Western aging populations is specific and conducted across 4 distinct institutions and 3 distinct methodologies. A randomized controlled trial from Johns Hopkins University, the institution where sulforaphane was first identified and characterized, enrolled 97 adults in a high-pollution region of China. Daily consumption of a broccoli sprout beverage for 12 weeks weeks produced a 61% increase in the urinary excretion of the carcinogen benzene and a 23% increase in acrolein excretion. That is not a marker of theoretical protection. That is a documented, measured acceleration of the body's clearance of cancer-initiating compounds from living tissue produced by a dietary intervention. A clinical trial from the University of Illinois enrolled 40 adults with type 2 diabetes in a 4-week broccoli sprout extract intervention. At the end of 4 weeks, 8-OHDG, the validated biomarker of oxidative DNA damage, had been reduced by 18% compared to placebo. No adverse events reported. A measurable reduction in the specific molecular marker of DNA damage that has been accumulating in the viewer's body for decades, from 4 weeks of daily consumption. A prospective study from the National Cancer Institute tracked dietary isothiocyanate intake, isothiocyanates being the compound class to which sulforaphane belongs, across a cohort of 29,361 adults over 11 years. The highest quartile of isothiocyanate consumption was associated with a 37% reduction in overall cancer mortality compared to the lowest quartile. 37%. 11 years. 29,361 people. And laboratory and early clinical research from MD Anderson Cancer Center, breast and colon cancer cell lines, while leaving normal cell function completely unaffected. That selectivity profile, suppressing the inflammatory pathway in cancer cells without harming normal cells, is precisely what pharmaceutical NF-kappa B inhibitors are in clinical development trying to achieve. None of them have achieved it safely yet. A dietary compound from a 3-day-old sprout has. What I am about to walk you through is the section that most people watching this video will never reach. And it is the only section that converts everything above into something you can actually do, starting today. Stay with him. The food is broccoli sprouts. Not mature broccoli, not broccoli powder from a health food store. Fresh broccoli sprouts, either grown at home or purchased fresh, consumed at 3 to 5 tablespoons daily, which is approximately 30 to 50 grams. Consumed with the first meal of the day, during the morning window when NRF2 activation produces the most sustained downstream gene expression across the waking hours. 2 preparation warnings that I need you to hear before anything else. First, heating broccoli sprouts above 140 degrees Fahrenheit destroys myrosinase, which is the enzyme naturally present in the sprout tissue that converts glucoraphanin, the inactive precursor compound, into sulforaphane, the active NRF2 activator. When you cook the sprouts, you destroy the enzyme. The sulforaphane never forms. You are consuming the raw material without the biological manufacturing process that produces the active compound. The sprouts must be eaten raw or added to dishes that have already cooled below 140 degrees Fahrenheit. Second, if you are considering a commercial broccoli sprout powder instead of fresh sprouts, confirm that the product label specifically states it contains active myrosinase. Most commercial broccoli powders are heat processed during manufacturing, which destroys the enzyme before the product reaches you. You would be purchasing glucoraphanin without the conversion mechanism. One preparation instruction that most people skip entirely: chew the sprouts thoroughly. Thorough chewing is not a comfort recommendation. It is the activation step. Chewing physically ruptures the cell walls of the sprout tissue, bringing glucoraphanin into contact with myrosinase and initiating the sulforaphane conversion inside your mouth before you swallow. Swallowing sprouts without adequate chewing bypasses this primary activation and substantially reduces the sulforaphane your body ultimately receives. The home sprouting method is what I recommend for potency, cost, and consistency. Broccoli seeds purchased in bulk, placed in a mason jar with a mesh sprouting lid, rinsed twice daily, ready to eat in 3 to 5 days. The cost per daily serving is approximately 15 to 20 cents. The NRF2 activation is pharmaceutical grade. The jar sits on your kitchen counter. Before I moves to the close, one question. How old are you? Write your age in the comments right now. I reads every comment on this channel, and your answer will directly shape the next video he makes for you. 4 mistakes that will defeat this protocol even when every intention is correct. Mistake 1. Using mature broccoli instead of sprouts. Mature broccoli contains approximately 1 to 5 milligrams of glucoraphanin per 100 grams. 3-day broccoli sprouts contain 50 to 100 milligrams per 100 grams. Substituting mature broccoli means consuming 2 to 5% of the sulforaphane precursor content the research was built on. The food category is correct. The biological concentration is clinically irrelevant. Mistake 2. Cooking the sprouts. Adding broccoli sprouts to a hot soup, a warm grain bowl, or any cooked preparation above 140 degrees Fahrenheit destroys myrosinase and prevents sulforaphane formation entirely. You are consuming glucoraphanin without the enzyme that converts it. The raw material arrives. The active compound never forms. Mistake 3. Swallowing without chewing. Thorough chewing is the mechanical activation step that ruptures cell walls and initiates the myrosinase glucoraphanin conversion in the mouth. Swallowing sprouts largely unchewed bypasses the primary conversion site and produces substantially less sulforaphane in the digestive tract. Chew deliberately, every time. Mistake 4. Consuming sporadically rather than daily. NRF2 activation from sulforaphane is cumulative. Consistent daily signaling over a minimum of 4 to 8 weeks is required to produce the sustained downstream gene expression that the research outcomes were built on. Sporadic consumption activates the pathway intermittently. Sustained daily consumption builds it. Your NRF2 protein is present in every cell your body contains right now. It has not been consumed by aging. It has not been deactivated by disease. It is sitting in its keep one locked dormant state at this moment, waiting for the sulforaphane signal that will release it. The over 200 downstream protective genes that NRF2 activates the glutathione production pathway, the phase 2 detoxification enzymes, the NF-kappa B suppression mechanism are all encoded in your genome and all fully responsive to the activation signal. The 8-OHDG oxidative DNA damage that has been accumulating in your tissue for years will begin showing measurable reduction within 2 to 4 weeks of consistent daily consumption, as the University of Illinois trial documented. The viewer who grows a jar of broccoli sprouts this week is a measurably different biological entity in 30 days than the viewer who closes this video and does nothing. The circuit breaker panel has not been damaged. It simply has not received the signal. I have just delivered it. An estimated 1.9 million Americans will receive a new cancer diagnosis this year. The overwhelming majority of them will never have been told by a physician that a dietary compound capable of activating their cellular DNA repair system and selectively suppressing NF-kappa B and cancer cell lines was available to them for 20 cents a day. You have just received that information. Think about the person in your life who was recently told their inflammatory markers are elevated, the spouse managing the aftermath of a cancer diagnosis, the close friend whose physician recommended watchful waiting without offering a single dietary intervention. Sharing this video is not a social media gesture. It is a biological act of care for someone whose NRF2 pathway still works and whose physician has never sent it the signal. And if sulforaphane is the activation compound that initiates DNA repair, the gut microbiome is the conversion environment that determines how much of the glucoraphanin in your broccoli sprouts actually becomes active sulforaphane after you swallow it. Next video, it covers the 3 specific gut health interventions that maximize that conversion rate and extend sulforaphane's biological window of activity dramatically. Watch that video next. These two pieces belong together.